This is Mr. Beck Does Your Homework. This is AP Physics, Homework 9.2, question number 13 and 14. 13 says, 3 positive charges are arranged as shown. So I've got distances in meters, and I've got the charges in nanocoulombs, nanocoulombs, nanocoulombs. It says, find the magnitude of the electric field at the fourth corner of the rectangle. The Coulomb constant is. So I've got, if I complete this rectangle, then I've got this point up here that I'm trying to find the electric field. Similar to previous problems, I'm going to have an electric field from this one pointing in some direction. I'm going to have an electric field in this one pointing in some direction. I'm going to have an electric field from this one pointing in some direction. But since this is 7 nanocoulombs and this is 3 nanocoulombs, these two are not going to give equal electric fields. So what I'm going to have to do is find the x and y component of all 3 of these. Actually, this one is going to be all x. This one is going to be all y, and this one is going to be some x and some y. So what you're going to have to do is find the E field from this one, which is going to be pretty simple. So the E for the first one, I'll call this one 1, and this one 2, and this one 3. So E for the first one is just going to be KQ over R squared. So that's going to be 9 times 10 to the 9th. Or 8.99 if you want, times Q, which is 3 nanocoulombs. That's 3 times 10 to the minus 9th coulombs, divided by R squared is 0.1 squared, 0.1 squared. That's going to be my first one. And that one is going to be straight up for me. This is positive. If you had negative, it would be straight down. But that is all in the y direction. So that's a y world. Let me jump to E3. The electric field from the third one is going to be KQ over R squared, and that's this Q. So this one is going to be 9 times 10 to the 9th times the Q is 7 times 10 to the minus 9th, divided by R squared. R is also 0.1, so that's 0.1 squared. This one will give you an answer that is all X world. That's all horizontal. So this one is just directly to the right. For me, the plus would mean that it's going to the left. If you had a negative, it would be attracted. Now E2 is a little complicated because you got to figure out what R is. So it's going to be KQ, again, KQ over R squared. But R squared is going to be, since this is a 0.1 by 0.1, it's a square, I want to find this side. So R is going to be, it's going to be like 0.1 radical 2. So I've got 9 times 10 to the 9th. For my K. My Q is going to be 7 times 10 to the minus 9th. And my R squared is going to be 0.1 times the square root of 2, because it's a 45, 45, 90 right triangle. And then take that whole thing and square it, which is pretty obvious there. So take the whole thing and square it, and that'll give you that. And that one is my monster. Okay, so that one is a monster. To figure out how much this is in one direction and this is in the other direction, you've got to do a little trig and split that into its 2 components, which I think is just dividing by radical 2. Yeah, it should, since it's a 45-degree angle. So I think if you take this and divide it by radical 2, you'll figure out your monster in the X world and your monster in the Y world. Now I've got Y world, add those together. For me, they add together because this is a positive, that's a positive, that's a positive. So the Y component of this one will be pointing to the right because it's pointing up at an angle. So the Y, sorry, to the left. So the Y points to the left, matches this Y. Sorry, I'm talking X. My X is to the left, this X is to the left, and this X is to the left. Both of these Y's are up straight. So I would take my total, take my X and Y, figure out my total X, figure out my total Y, Pythagorize them back together, and get my resulting vector. There, again, might be a shortcut to that with trig, but this is kind of the down and dirty way to do it. The next thing says, what is the direction of this electric field as an angle measured -180 and 180, measured from the positive axis? Well, that means you want to take this angle over here. So figure out your trig. Maybe if you measure this angle and subtract it from 180, that would be great. This would get you up to 180. This would get you down to negative 180, so -1, -90, up to -180. So whichever way your vector is pointing, move from the x-axis either around this way with negatives or around this way with positives, but figure out what that angle is based upon your x and y component and inverse tangent or something like that.